Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Good day, viewers, and you're welcome once again to class. Today we shall be considering angle of elevation and depression. I will give you a typical example to define elevation and depression. If you see a little boy looking at a mango fruit from the ground, I'm sure the little boy will be looking at the mango, tilting his head like this, looking towards the mango fruit. The process by which he views that mango fruit is regarded as elevation. That is an angle of elevation. While angle of depression can be described as a man standing on a 5-story building looking at little children playing at the ground floor, right? With those two examples, I'm sure you would be able to understand what we mean by what elevation and depression. Here we have a question that from a horizontal distance of 8 kilometers, a point observes that the angle of depression of the top and the base of a control tower are 30 degrees and 33 degrees respectively. Let me try to draw. Assuming this is my point observer, right? My point observer observe, and this is a tower. Let me assume this is the building, this is the tower. And he observes the top and the base at certain angles. He observes that the top is what? 30 degrees and the base 33 degrees. So let me add 3 degrees to 30 to give me 33. So if I form a triangle like this, right? That is this, when you have two lines, this angle here is alternate to the angle here. Therefore, we can say that if this is 30, definitely this will also be what? 30. And if this is 30, this will definitely be what? 30, because they are alternate angles. Good. So therefore, permit me to draw the diagram. This is the 30 degrees, and from here to here is said to be 33 degrees. So this little becomes what? 3 degrees. So since alternate angles are equal, this becomes 30 degrees and this becomes 33 degrees. Now we were told that the base of the tower, right, and this point are what? 8.5 kilometers. If the height of the tower is h, and I call this particular distance from the top of the tower to where the observer is as x, then we are asked to find the shortest distance between the point end and the base of the tower. To get that means I want to find what? This total distance here from this point to this point. So the first question, I will extract this triangle from there. So if I call this point y, the whole angle here is what? 33 degrees. and I call this place, of course, this is 8.5 kilometers. Therefore, looking at the situation here, we have this as adjacent and this as what? Hypotenuse. So using cosine 33 degrees, which is what? Adjacent, which is 8.5 kilometer over hypotenuse y. Y will become what? Y will become 8.5 over cosine 33 degrees. Now, what is cosine 33 degrees from our calculator? Cosine 33 degrees is what? 0.8386, and this is 8.5. Therefore, 8.5 divided by 0.8386 will give us 10.1359 kilometers. But remember, we are asked to leave our answer to three significant figures. So approximately, this becomes 10.13 kilometers. This is the three significant, 3SF, three significant figures. So this is the first part of the question. Now, the other part of the question says we should find the height of the control tower, which is just h. So to do that, to form two equations, and the first equation is this. Looking at this smaller triangle here to here, I can say that my tan 30 degrees, which is opposite over adjacent. Remember, this is 8.5, therefore this is also 8.5, which is x over 8.5. So from here, x will become 8.5 times tan 30 degrees, right? Call this equation 1. Call that equation 1. Then let's form a second equation. Now, I want to use this bigger triangle to form tan 33 degrees equals to opposite. Now, the opposite here is x plus h, because everything forms my opposite. So I have x plus h together over adjacent is still what? 8.5. Therefore, if I cross multiply, I will have 8.5 times tan 33 equals to x plus h. Therefore, if I move h to this particular point, I will have my x to be equals to 8.5 tan 33 degrees minus h. This is equation 2. Now, what do you observe? We observe that equation 1 is x equals to this. Equation 2 is also x equals to this. So therefore, it means that equation 1 can be quoted to equation 2 since both of them are x, right? So therefore, 8.5 tan 33 degrees minus h is equal to what? 8.5 tan 30 degrees. Therefore, collecting like terms, I will move h to this place. I will have that to be h. Then if I move this here, I will have 8.5 tan 33 degrees minus 8.5 tan 30 degrees. So let me see what this will give me using the calculator. 8.5 times tan 33 degrees will give me 5.51 4.99. Then 8.5 times 30 will give me 4.9075. So let me subtract this from this. So 5.5199 minus 4.9075 will give us 0.6124 kilometers. Then we can approximate this value to three significant figures as well. So h is approximately 0.612 kilometer. That is a three significant figure. We've come to the end of this class. This is Prince Maths Clinic. Kindly subscribe to this channel so that you can watch more interesting videos, and also give this video a thumbs up and share this video to your friends and colleagues. Bye for now.